Fourth grade, lesson 4.9 is modeling division with regrouping. We're now getting ready to work our way into the algorithm that you will begin to use. This is going to model what's happening so that we can move into the algorithm you would use for division on a regular basis. Let's have a look at how this models out, how the pieces fall into place. Our essential question is, how can you use base 10 blocks to model division with regrouping? We're back to those base 10 blocks. A rod is 10, and then the ones are the broken up pieces. 10 of those broken up pieces, or those units, make one rod. You remember those from the beginning of the year. So let's investigate using these as tools. The librarian wants to share 54 books equally among 3 classes. How many books will she give to each class? So they asked us to draw 3 circles to represent the classes, and they did that there. 1, 2, 3 circles to represent the 3 classes. And then we will use base 10 blocks to model 54. And we're showing 54 as 5 tens or 5 rods, 1, 2, 3, 4, 5, and 4 ones, 1, 2, 3, 4. And here I've drawn those here, 1, 2, 3, 4, 5 tens, that's 50, 1, 2, 3, 4, 54, and we're sharing them equally among 4 classes. They want us to share the tens equally first. We're going to take the tens rods and share them equally. So this tens rod will go into here. This tens rod will go into that class. And this tens rod will go into that class. That's shared equally so far. That's nicey nice. Okay. But here's the problem. If I give this tens rod to this one and this tens rod to this one, this class is going to be like, hey, that's not fair. Why did you do that for them? So I'm not going to hand these out. I'm going to do something else instead. If there's tens left, and we do have 2 tens rods left, regroup them as ones. So we're breaking them all apart. We know that this is 10 ones and this is 10 ones. And then we will share those amongst the 3 groups. And so I would break these apart. Oopsie. Break these apart. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 20. 1, 2, 3, 4, 24 left. So now I'll pass those out. We get 1, 2, 3. That takes care of those 3. 4, 5, 6. There's those 3. 7, 8, 9. There's those 3. There's one more there. 10. Then 2 out of here. 11, 12. Then we've got 13, 14, 15. There's 3 more. 16, 17, 18, 19, 20, 21, and 22, 23, 24. That took care of the rest that were there. So how many tens are in each class? They have 1 tens rod each. And then how many ones in each group? They have 1, 2, 3, 4, 5, 6, 7, 8. Each of them has 8 ones. So the librarian will give 18 books to each class. Now the modeling is just helping your brain make a connection. You're not going to have to draw all these bars and rods or use bars and rods all the time. Why did we need to regroup in step C? We had these tens left, right? Or these tens left, right? There weren't enough tens to just say, oh, okay, we're going to be fair about it. This guy would have had some left out. He wouldn't have got a tens rod. That's why we broke them apart, so we could share them fairly. The goal was to share fairly. So we needed to break them apart to share them fairly. How can you use base 10 blocks to find the quotient of 92 divided by 4? All right, I'm doing 4 groupings, so I would draw 4 circles. There's that. Then I need to make 92 out of my rods and units. So I'm going to use 9 rods because there's 90. So there's 9 tens. So we're going to use 9 rods. And then I will use 2 ones. So I will use 9 tens and 2 ones, 9 tens and 2 ones. and I'm going to pass them out to my 4 groupings fairly or evenly. So this one would go here, this one would go there, this one here, this one there. I can do some more. That's where I'm at so far. There's still enough for each of these 4 to get another set of 10s. These 4 here can get passed out. So there's another set for all of them. And then I have 1 set of 10s left over. I need to be fair about it, so I will break this up into 10 pieces. There's the 2 there also, so you got 10 and 2 more, that's 12. Now I have 12 ones that I'm going to pass out fairly, and I'll just count them out. 1, oops, that's not going to work. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lands perfectly. Everything's fair. Everyone's happy. How much did that end up being? Well, I have 2 10s rods, so that's 20. 2 10s. And 3 of the single units, 3 1s, equals 23. Everybody will get 23 of whatever that is, fairly. So that's what's happening visually for your brain to know we're fairly sharing things apart. And then if we have some left that we've got to break apart so we can continue sharing fairly, then we're going to do that. The next step is going to show you what's happening with the algorithm that helps us do that without rods and units. Okay, so this takes us into how we use that algorithm. We're going to use the quick picture at the bottom down here of the page to help us divide, and we'll record each step. We're finding 76 divided by 3. 76 being divided fairly into 3 equal pieces. It gets written this way, 76 divided by 3. So we would model 76 as 7 10s and 6 1s. 1, 2, 3, 4, 5, 6, 7 10s, and 1, 2, 3, 4, 5, 6 1s. So this first part, we're only going to worry about the 10s. We're completely ignoring, like I'm hiding that 6 1s right there. I'm completely ignoring that, right? We would share the 7 10s equally among the 3 groups. So how many groups of 3 can I group around and get as close to 7 as possible without going over? Or how many times can I split 7 up into 3 equal groups? So we can draw it. We can say, okay, there's 1, 2, 3, 4, 5, 6, and that 7th one is kind of left there because I can't do that one fairly. So I can split this where each group gets 2, or 3 times 2 uses up 6 of those 10s. If each of them got 2, if all of the 3 groups got 2, then that would use up the 6 10s. That's what's going on here. How many of those 10s are left? Well, we'll do 7 minus 6, and we end up with 1 10 left. Okay, so we have the 1 10 left, right? Now we would break that 1 10 up into 10 pieces so that we can continue breaking them up fairly. So it's the 10 pieces plus the 6 that were still there. So we just bring down that 6. So now we know we have 16 1s that we have to share out. So I would pass out these 16 1s to each of my 3 groups. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, no, that's as much as I can put in there, keeping it fair. So each of them would get 1, 2, 3, 4, 5. 5 of the 1s is what each of them would get. 3 times 5, right? 3 groups with 5 in them is 15. And then I would subtract to find out how many are left over. There's 1 left over. So what that gives me is 3 groups of 10, 20, 21, 22, 23, 24, 25. 3 groups of 25 and 1 item left over when we were passing them out. So for 76 divided by 3, the quotient is 25. Each of them would get 25, and the remainder is 1. This can be written as 25 remainder 1. It also could be written as 25 with 1 out of the 3 that we were dividing left over. Okay, this is clearly going to need some practice, right? Your brain's probably going, oh, I kind of get it. I don't know. I don't even know if I get it, Miss Sanchez. That's okay. We're going to practice them. Be patient with your brain. You'll get this. Okay, and so they want us to divide using the base 10 blocks. This is number 1 on the share and show. I'm going to do it both with the step-by-step on the algorithm and using the base 10 blocks, so your brain is making all of those connections, and with practice, it should all click together, hopefully. So we start off with 48 divided by 3. This is 48 being divided into 3 equal pieces. So visually, I'm going to have 3 equal circles, and I am going to use 48 for my base 10 blocks. I'm going to use 4 10s, 4 rods, and 8 ones. So there I have 4 10s and 8 ones to make 48. Here's how it looks using the algorithm. So it says 48 divided by 3. 48 divided by 3, right, says 48. That's what's being split up. What's being split up goes into the house, divided by 3. Okay. I'm going to just focus on my base 10 blocks. So if I'm using the algorithm, I'm only looking at this 4, and I'm completely ignoring this 8. Just looking at how many 10s can I pass out. So I'm going to pass 1 out to here, 1 to here, 1 to here. Oh, and I have 1 left over, and that wouldn't be fair. So I can only pass out 1 to each section, 1 to each section, 1 to each of the 3 sections. 1 times 3, 1 times 3 is 3, right? So I passed out 3 of them. 1 times 3 is 3. I passed out 3 10s. How many 10s were left? 4 minus 3 is 1. I had 1 10 left over here, right? So I have that 1 10 that I will break into its 10 individual pieces, and I'm going to put it together with these 8 that are left. And in this algorithm, all you're doing to show that is you take that 8 and bring it straight down. With 1 10 left and 8 ones left, I now have 18. Okay, so I have 18 ones that I'm going to pass out into these 3 groups evenly. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. So each of these 3 got 6 ones. 3 times 6 is 18, right? 6 times 3 is 18. And when I subtract 18 minus 18, there's none left over. And of course, we saw that none got left over. So each of the 3 groups got 1 10 and 6 ones, 1 10 and 6 ones, for a total of 16. That's how you do that. Let's take a look at another one, because this is going to take some practice. Okay, and if you think you're ready to try it, you can go ahead and try it. But if you don't think you're ready to try it by yourself, and then check your answer, that's okay. I wouldn't expect at this point for you to be ready to do that. This is going to take some time for your brain to digest. Again, we're modeling using base 10 blocks, but I'm going to do it both ways, where I modeled down here and showed you the walkthrough of the algorithm, because that algorithm is going to be what we eventually use. But I want your brain to know why we do things the way we do it. So we have 84 divided by 4. That is 84 being split up equally into 4 pieces. So I'm going to do 4 circles to represent the 4 that we're splitting those up into. 1, 2, 3, 4. And then I'm going to draw out 8 10s and 4 1s. 8 rods and 4 ones. 1, 2, 3, 4, 5, 6, 7, 8 tens and 4 ones. There we go. Let's do that as the algorithm. This is 84 that is being split up into 4 equal pieces. 84 divided by or split up into 4 equal pieces. Okay, we're going to focus only on the tens rods. We're not worried about the ones. We're focused only on the tens rods. We're not even looking at the ones right now. If I pass out these 8 rods to 4 equal groups, how much will each get? So that's what we're going to do right now. We're going to pass these out equally as we can to these 4 groups. So 1, that's that one. 2, that's that one. 3, there. 4, there. 5, 6, 7, 8. Oh, that's perfect. Okay. Each of them got 2, correct? 2 times 4 groups was 8. 4 times 2 is 8. And then there were no tens rods left. That's nice. Okay, so I don't have to break up any tens rods because there were none left. I just have to break up these ones, the 4 of them. I'm going to bring that 4 down. So now I can look at those ones. I can invite them to play. Okay, the ones place. You can come play now. And I will pass these out. 1 goes here. 1 goes here. 1 goes here. 1 goes here. That's all of them. So each of these 4 got only 1. 1 4 times is the 4 that were there. 1 times 4 is 4. So were there any left? No. How many did each of those groups get, of those 4 groups get? Each of them got 21. This is always the quotient, the answer. And if you have something here, that's your remainder. That's what's left that couldn't be passed out without being fair. So here it is visually, 10, 21. We took all of these 84, passed them out fairly, and every group of the 4 groups got 21 fair. Everybody's happy. Okay, you might be at a stage where you're ready to pause and try this one. Maybe not, I don't know. But if you feel like you're ready to and you get stuck, that's okay. Try it, see what happens. But if you're not ready for that, don't worry, it's okay. I'll do it with you. 72 divided by 5. This is 72 being split up equally into 5 pieces. I'll do it in the algorithm form first. 72 is what's being split up, and we're dividing it into 5 equal pieces. 72 divided by 5. 72 divided by 5. Okay, let's do this in our picture form. We're dividing it into 5 equal groups. 1, 2, 3, 4, 5. And I have 7 tens and 2 ones. 1, 2, 3, 4, 5, 6, 7, and 2 ones. That is 72. I'm going to pass out the tens only. I'm not worried about these. I'm going to pass them out fairly, as fairly as I can. So same thing on this algorithm. I would be ignoring this 2. I'm not worried about these 2 ones right now. I'm not worried about these. I'm only worried how many of those tens rods can I pass out fairly without upsetting anybody. So I would pass out. I'm going to use a different color this time to help kind of make the point here. I would take this one, this one here, this one here, this one here, this one here. And look at, there's 2 rods left. There's 5 people wanting them. And so I can't say, oh, rod, you go here, this rod go there, and I'm sorry, you guys, too bad, so sad. We can't do that in division. We got to be fair. So everybody of the 5 is getting 1 each. Everybody's getting 1 each. 5 times 1 is 5. That used up. If every one of the 5 got 1 each, 1, 2, 3, 4, 5 of the rods were used up. How many rods were left? You can see them over here. 2 rods were left. 7 minus 5 is 2. Okay. Then I still had these 2 ones, so I can bring these down. They can play now. So I had 2 rods left. That's 20, and 2 ones left. Now I have 5, being split into 5 equal pieces is 22 ones. So I've got 22 ones. I'm going to use blue to pass these out. And I'm going to start passing them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, 20. I would need 25 to continue going, right? And I don't. I only have 22, so I got to stop there. So the best I could do, keeping it fair, is give each of them 4. 4, 8, 12, 16, 20. 4, 5 times over. 4 times 5 is 20. And I still had 2 left over that I can't pass out without, but still be fair. So my quotient, my answer, is going to be everybody gets 14, a 10 with 4 ones. Everybody gets 14, but there's 2 left over. So I could write that as 14 remainder 2, or I could write that with 14 with 2 left out of the 5 that we were dividing. That's your answer. That's your quotient. Okay, the last practice one, and then hopefully you're understanding this well enough we can continue practicing as a group in class, but hopefully this clarifies everything. We want to divide. We're going to draw the quick picture and record the steps. Here's the steps in the algorithm, and then we're going to do it as a picture too. So 84 divided by 3, 84 divided by 3, 84 being split into 3 equal pieces. So I will draw my 3 equal pieces. 1, 2, 3 equal pieces. And then I've got 84 that I want to model. That's 8 tens and 4 ones. 1, 2, 3, 4, 5, 6, 7, 8 tens, and 1, 2, 3, 4 ones. Okay, 84 split into 3 equal pieces. Only passing out the tens rods first. Let's get those out of the way first. That's dealing with the tens rods only, the 8 tens rods, and completely ignoring the 4 ones. How many can I get? So 3 times what number gets me as close to those 8 as possible without going over. So here we go, passing them out. There's 1, 2, 3, 4, 5, 6, and oh no, there's 2 left, but there's 3 that need them, so I can't go any further than that. So each of them got 2. And 3 times 2 is 6. 2, 3 times is 6. 1, 2, 3, 4, 5, 6, right? So there were 6 rods used up. How many did that leave me with? 8 minus 6 is 2 rods. Now, these 2 rods that are left, I'm going to break them apart, 20. And then I have the 4 ones that were still there. I'll bring those down, 4 ones. That's hard to see. I'll put it back to red again. 4 ones. And now I'm going to pass out 24 of the units into the 3 groups. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And there I did that. Each of them got 8. And hopefully you're starting to recognize, oh, you know, I had 3 and 24. I know my multiplication facts, 3 times 8 is 24. It's going to pass out evenly 8 times. Those math facts, those multiplication facts we've been working on help you here. So if I need to split 24 into 3 equal pieces, I'm asking myself 3 times what number gets me close to 24 without going over? Well, 3 times 8 does. Each of them got 8. And 3 times 8, or 8, 3 times is 24. And I have 0 left over. So my quotient, the answer, is 28. Each of the groupings got 2 tens and 8 ones for 28. That's what this lesson is about. Now, you are going to move towards using this algorithm in future lessons. What this lesson wanted to help you understand is what is happening. Why are we ignoring this ones place for right now and just dealing with that? So hopefully that helped clarify for you what we're doing as we move towards using the algorithm in the future. We'll practice more in class if it's necessary, probably will be necessary, but hopefully it's starting to make sense.